everyone, and welcome to lesson 8.2, day 2. Today we are going to talk about using trigonometry to help us solve for missing sides of our right triangles. So a reminder when you are going to round, okay, something to the nearest hundredths place. That means you are rounding it to 2 decimal places. Tenths is 1 decimal place. So what we're going to do is we're going to use our calculator to approximate some values. So those of you with a graphing calculator, you want to make sure you go under the mode menu and you scroll down, and you need your calculator to be in degree mode. So you will hit enter and then second quit out of this. Okay, you must use a calculator to approximate these. And the first one you will see here is cosine of 32. So we're going to take cosine 32 in the calculator. And again, if we're going to the nearest hundredths, that is 2 decimal places. So the 8 will make the 4 round up, and we would get 0.85 as our value. Okay. Next one, when we do sine of 72, we have 0.951. The 1 will make the 5 stay put. So 0.95 would be our answer there. And then last but not least, tangent of 64 degrees will be 2.050. The 0 will keep the 5 the same. So 2.05. Now, how can we then use our calculator's approximations of these values to actually solve for sides of our triangles? Okay, we are going to end up setting up equations that we have to solve. So when the variable is in the numerator, so for instance, let's say I have sine of 30 and x value is on the top, I have a number on the bottom. What ends up happening is we end up multiplying both sides by that denominator value, right? Because what ends up happening is we cancel out then that denominator, and x will just equal 7 times our trig value. What about though when the reverse is happening? Let's say we have sine of 30 degrees and the 7 is on the top, the x is on the bottom. Well, what our shortcut is on this one is we call this switch and divide. Now, why are we switching and dividing? Well, here's the thing. If I started solving like I solved the last problem, I multiplied both sides by x to cancel this out. I would have x times the sine of 30 equals 7. Well, I need x by itself, so I end up dividing both sides by the sine of 30 so that this cancels out. So I end up getting x will equal 7 divided by sine of 30. So this is essentially the flip-flop of what we had at the beginning, right? These two switch spots so that we end up just switching sine of 30 and x, and that will end up giving us what we would need for our answer. Okay. Now, let's actually use that. Okay, so on this first one, we notice that our x is in the numerator. So again, we want to multiply both sides by that 23 so that we would have 23 times the sine of 48 degrees. And that gives us about 17 if we're rounding to the nearest hundredths, 17.09. So again, we just type this in to get that 17.09. The next one, our x is in the denominator. So this is an example of where we are going to want to switch and divide. So to get x, we're going to just take 13 and divide it by, not the sine, the cosine of 64. So we're going to take our calculators, and this time it's 13 divided by cosine of 64. And this time we end up with 29.66 as our final answer. Okay, last example together. Again, we have this x in the denominator. So this is an example where we will switch and divide. So in this case, x is going to now equal 37 divided by tangent of 47. So x equals, when we divide in our calculators, 37 divided by tangent of 47. X is 34.50. And finally, there is one example for you to try in order to solve for x. All right, now, how are we going to actually be able to set up those equations for us to solve? Well, first and foremost, we are going to start each time by circling the reference angle they are giving us, and then we are going to label all of the sides based on that angle, the opposite, the adjacent, and the hypotenuse based on what we are given. Then, based on what we are given, we want to decide which of the following should we use: sine, cosine, or tangent. We will write our trig equation based on that info and solve for x. So if we look at our first example, 30 degrees is my reference angle. I don't know anything about the hypotenuse, but I'm given the opposite leg and the adjacent leg. So if we think about SOHCAHTOA, if I don't know anything about my hypotenuse, I cannot use sine or cosine to solve this. I need the tangent because I'm looking for my opposite. I'm given my adjacent. So when I set this up, notice my angle, my degrees, goes with the trig, and that's going to then equal my opposite over my adjacent, right? Those side lengths. Well, this time the 7 is in our denominator, so we need to multiply both sides to get our x value by itself. So 7 times the tangent of 30 degrees, oops, not 330, excuse me, 30 is 4.04. Okay, and this one says to round to the nearest tenth, so we'll just say 4.0. The next one, if we circle our reference angle, this time we are given that the angle is 20. We are given the opposite side, and we are looking for the adjacent side. So again, similar to the last question, we want to use tangent because we don't know anything about the hypotenuse, so cosine and sine are not useful to us. We have 20 degrees, so opposite then over adjacent. This time, my x is in the denominator. So it will need to switch with tangent of 20 so we can find out what that x value is. So 9 divided by the tangent of 20 is about 24.7 as our missing side length. 2 examples left. Okay, next one, we are given this 28-degree angle. That is the adjacent side, and we are looking for the hypotenuse. So again, consulting my list, if I have the adjacent and I'm looking for the hypotenuse, this time that's going to leave me using cosine. So the cosine of my angle is going to equal adjacent over hypotenuse. This is another example of switch and divide because my variable is in my denominator. So x equals 11 divided by the cosine of 28. So 11 divided by cos 28 is about 12.5. So that would be our missing side hypotenuse length this time. And then last but not least, we are given angle A is 24. This time the opposite leg and the hypotenuse are given / what we are looking for. So we will want to use a sine. My angle is 24, opposite over hypotenuse this time. To solve for x, I'm going to multiply both sides by 53. So when we multiply 53 times the sine of 24 degrees, we get about 21.6 as our final answer. And again, that would be our missing side length right there. All right, 2 final examples for you. Okay, using 47, you want to set up and solve an equation, and then using 27, set up and solve an equation. Thanks everyone for watching. We'll work more with solving sides of these right triangles in class.